Welcome to my channel, where your adventure into the future starts right now. Step into a vibrant universe filled with groundbreaking technology, breathtaking alien landscapes, and exhilarating sci-fi narratives that challenge your imagination. From daring explorations of distant galaxies to haunting journeys through dystopian societies, we uncover the most captivating stories and innovative ideas that will shape the world of tomorrow. Subscribe today and join us on an incredible intergalactic voyage that promises to inspire and thrill. The concept of extraterrestrial civilizations adopting Earth's waste management systems to improve galactic ecology may seem like a fantastical idea at first, but it becomes a more plausible and intriguing possibility when considering the growing need for sustainable practices in an increasingly interconnected cosmos. Waste management, in the context of Earth, has long been a significant concern for humanity as it grapples with the consequences of overproduction, consumption, and the resulting environmental degradation. However, when viewed from a broader, interstellar perspective, waste management takes on a new dimension. It is no longer merely a local challenge to Earth's inhabitants, it becomes a universal one, tied to the future of intergalactic ecological balance. As Earth's environmental challenges intensify, the technology and methodologies employed to manage waste become not only a matter of survival but a key tool in preserving the planet's ecological integrity. These innovations are closely tied to broader sustainability efforts aimed at reducing pollution, managing resources more efficiently, and mitigating the effects of climate change. Over time, humanity has developed complex systems of recycling, reusing, reducing, and safely disposing of waste, along with increasingly sophisticated technologies for waste-to-energy conversion, landfills, and biodegradable alternatives. These strategies have not only sought to address the environmental consequences of waste accumulation but have also focused on fostering a more harmonious relationship between human activity and the natural environment. And as humanity reaches out into the cosmos, it becomes clear that these systems, designed to address earthly problems, might offer valuable lessons for civilizations beyond our planet. The first step in understanding how aliens could adopt Earth's waste management systems begins with considering the shared ecological concerns that any advanced species might face. In a universe teeming with life, it is likely that other civilizations, whether organic or technological, would face similar environmental issues as humanity. Just as humans have struggled with pollution and unsustainable resource extraction, extraterrestrial societies might encounter analogous challenges. Whether on planets with vast industrial infrastructure or in spacefaring societies navigating the complexities of long-term interplanetary travel, the question of waste management would inevitably arise. It is important to understand that waste, in this context, refers to anything that a civilization produces that is no longer useful or wanted. This waste could take on various forms: gaseous emissions, hazardous chemicals, organic byproducts, electronic refuse, or even the waste generated by a technological society's machines. No matter the form, waste represents a challenge to maintaining ecological balance, as it can accumulate, disrupt ecosystems, and, in some cases, threaten the survival of an entire civilization. For this reason, the idea that alien species could adopt Earth's waste management systems becomes more than a theoretical exercise in interplanetary cooperation. It becomes a fundamental avenue for galactic ecological sustainability. Humanity's journey toward effective waste management began in the early days of industrialization, when the rapid growth of cities and manufacturing led to the accumulation of waste products that had nowhere to go. Early waste disposal systems were rudimentary, relying on dumping refuse in open pits or, worse, into rivers and oceans. As industrialization advanced, these practices resulted in significant environmental harm, including pollution, disease outbreaks, and habitat destruction. Over time, as environmental consciousness grew, the need for more sustainable waste management practices became evident. Governments, businesses, and environmental organizations began to work together to find innovative ways to handle waste without causing further ecological harm. The introduction of recycling systems was one of the first steps in reducing the environmental impact of waste. By reprocessing materials and turning them into new products, humanity could reduce the need for virgin resources, minimize energy consumption, and decrease the amount of waste sent to landfills. As recycling technologies advanced, it became possible to recycle a wider range of materials, including plastics, metals, paper, and even electronic waste. These innovations allowed Earth to start mitigating some of the damage caused by overconsumption, offering a model for how extraterrestrial civilizations might handle their own waste challenges. In addition to recycling, the development of waste-to-energy systems became a key part of Earth's waste management strategy. These systems convert organic waste, such as food scraps and plant material, into usable energy in the form of electricity or heat. This technology proved especially beneficial for reducing landfill waste and providing sustainable energy sources in urban areas. By converting waste into a resource, humanity turned a potential environmental liability into a valuable asset. This approach could also be adapted for use in extraterrestrial societies, where waste could be repurposed to meet the energy needs of spacefaring civilizations or on planets with limited natural resources. However, while these methods of waste management have been highly effective on Earth, they also face limitations. Many of Earth's waste management systems still rely on finite resources, and some of the waste products generated by modern industry are difficult, if not impossible, to recycle or reuse. Furthermore, waste can take on many forms that pose significant environmental and health risks, such as toxic chemicals, plastics that do not biodegrade, and electronic waste that leaches harmful materials into the soil. These challenges have prompted humanity to look for more sustainable solutions, and some of these innovations could serve as models for alien civilizations seeking to address similar ecological concerns. One of the most important lessons that alien civilizations could learn from Earth's waste management systems is the importance of a circular economy. A circular economy is one in which waste is minimized and materials are reused or recycled as much as possible. This stands in contrast to a linear economy, in which resources are extracted, used, and then discarded. A circular economy reduces the need for raw materials, decreases pollution, and promotes sustainable production and consumption practices. Earth's growing focus on creating a circular economy could serve as a model for extraterrestrial societies that wish to reduce their ecological footprint while continuing to thrive. The concept of a circular economy could be particularly relevant for spacefaring civilizations, where resources are limited and waste disposal presents a unique set of challenges. For instance, on long-duration space missions or on planetary colonies, waste management systems would need to be highly efficient and self-sustaining. As humanity moves toward colonizing the Moon, Mars, and beyond, the need for technologies that can recycle waste, produce food, and generate energy from available resources will be critical. This is where Earth's innovations in waste-to-energy systems, closed-loop water recycling, and organic waste composting could offer valuable insights for extraterrestrial civilizations. Beyond the practical applications of waste management, Earth's ecological practices also offer important philosophical lessons that might resonate with alien societies. Many of Earth's environmental movements, such as the focus on reducing waste, minimizing pollution, and living in harmony with the planet, are rooted in a deep respect for the natural world. These philosophies emphasize sustainability, conservation, and the interdependence of all life forms. For alien civilizations that may have developed their own ethical and philosophical frameworks, these values could provide a basis for understanding the importance of ecological balance and sustainability in a galactic context. When thinking about how extraterrestrial civilizations might adopt Earth's waste management systems, it's important to consider the various forms that life and civilization might take. Some alien species may be highly technological, with advanced artificial intelligence and robotic systems capable of managing waste autonomously. Others may be more biologically based, with unique forms of life that interact with their environment in ways that are difficult to imagine. However, regardless of the specific nature of these civilizations, the fundamental principles of waste management, reducing, recycling, reusing, and minimizing harmful emissions would likely remain universal. Furthermore, the adoption of Earth's waste management systems by extraterrestrial civilizations could have far-reaching implications for galactic ecology. If these systems were implemented on a galactic scale, they could help create a more sustainable balance between industrial activity, resource consumption, and environmental protection across the galaxy. Just as Earth's ecosystems are interconnected, so too could the ecosystems of various planets be interlinked. The waste produced by one civilization might have cascading effects on neighboring planets, especially if that waste consists of pollutants or substances that are harmful to other forms of life. A galactic-wide commitment to sustainable waste management practices could help prevent ecological crises, promote cooperation between species, and ensure the long-term survival of life across the galaxy. The idea of a galactic ecological network in which civilizations adopt Earth's waste management systems is not merely theoretical. It is grounded in the practical realities of space exploration and the increasing recognition of the interconnectedness of all life forms. As humanity ventures further into space, the lessons learned from Earth's environmental stewardship will be critical not just for ensuring the sustainability of human colonies and missions, but for fostering peaceful cooperation with other life forms. In this broader context, the adoption of Earth's waste management systems by alien civilizations could represent a step toward universal environmental ethics, where the preservation of ecological integrity becomes a shared goal across the cosmos. Whether through the development of new technologies, the sharing of knowledge, or the cultivation of mutual respect for the natural world, the act of managing waste responsibly becomes an act of interspecies solidarity. Through this process, Earth's waste management systems could become a powerful tool for improving galactic ecology, fostering sustainability, and ensuring that all civilizations, human or alien, can coexist in a balanced, harmonious relationship with the universe around them. As humanity continues its exploration of the cosmos, the lessons learned from Earth's waste management systems could become part of a larger, intergalactic movement toward ecological stewardship. Just as humanity once adopted sustainable practices to protect its home planet, it is conceivable that other civilizations might one day look to Earth's example as they seek to address their own environmental challenges. The idea that alien species could adopt Earth's waste management systems is a testament to the potential for cooperation, innovation, and sustainability that lies ahead as humanity continues its journey into the stars. In this future, Earth's waste management systems will not only serve to protect the planet, but will become a vital part of a galactic effort to safeguard the delicate balance of life across the universe.